Hello there and welcome to Pluralsight. My name is Tim Werner and the name of this module is Wi-Fi Networking. In our Pluralsight learning path for the CompTIA A+ 220901 certification exam, we have a total of 5 courses. The first is an introduction to the series, then we devote each of the subsequent 4 to the matching content domains in CompTIA's A+ blueprint. Check the course notes for a link to the A+ website. Hardware was our first content domain. We're in the middle of the networking one right now. Then we have mobile devices and troubleshooting. Within this 8-module networking course, we begin with network cables and connectors, spend time on TCP-IP, both basics, sort of a global overview, and then a deep dive into specific ports and protocols. We're doing wireless networking presently, after which we'll get into small office, home office networking, internet connection types, network architecture devices, and networking tools. What are we going to talk about and learn in this module? First, I want to make sure that you're comfortable with radio frequency or RF communications, because that is, in fact, the technology that undergirds Wi-Fi. The main focus of this module is making sure you know the basic IEEE 802.11 Wi-Fi standards. You'll very likely see questions on your 22901 exam that ask you to differentiate, for instance, among B, G, N, and AC Wi-Fi. And if you don't know the answers, well, that's going to reduce your chances of passing the exam and earning your credential. The third subject deals with securing Wi-Fi. In particular, again, CompTIA wants us to know the major encryption protocols that are supported by the standard. Let's begin. Meanwhile, in the real world, as a working PC repair technician, some questions that you may likely see are: number 1, how do I secure my Wi-Fi? I'm, for instance, afraid of my neighbors surfing my internet connection and downloading illegal materials. That's definitely a common question you'll see among small office, home office customers and residential customers. Another question along those same lines: is it legal to ride my neighbor's Wi-Fi? I may not be in a position financially to buy internet service, but I do have an iPad, let's say, or a beat-up old laptop that does have a Wi-Fi antenna in it. I notice that my neighbor's network is unsecured. What is wrong, if anything, with that? We'll revisit and answer these questions at the end of the module, as usual. Our CompTIA A+ 22901 objective in this module is 2.5, which states that we need to be able to compare and contrast various Wi-Fi networking standards and encryption types. Getting comfortable with RF. RF stands for radio frequency, and this is a communications method that's been around for a long time for sure. If you walk up to a still pond, for instance, and throw a pebble, you'll see this radiation of water as the impact of that pebble spreads out in a circular way. Well, that's kind of how I imagine RF communications. We have, as you see on the picture at right, antennas that are broadcasting or emanating radio frequency signals at one or more different frequencies, and depending upon which frequency you're tuned into, you can capture that data stream. So the textbook definition of RF communications is that we use wireless electromagnetic signals for data communications, and that in the Wi-Fi standard, Y-Fi is the brand name for IEEE 802.11 Wi-Fi, the Wi-Fi that you know and love and I'm sure you use every day. As it happens, there exists a nonprofit organization called the Wi-Fi Alliance that actually has created a logo and standardized the brand name of Y-Fi. I just want you to know that bit of trivia so that you have the correct nomenclature. But anyway, as that second bullet point says, Wi-Fi nodes are both receivers and transmitters. As such, they're going to require one or more antennas to propagate the waves. So if you have, for instance, a Wi-Fi router at home or at your business, your chances are you see a physical antenna on that. On the other hand, if you hold up your smartphone, you may think, well, I don't see an antenna. I mean, it's true many years ago, like in the early 2000s, my wife and I, when we got our first cell phones, they were the candy bar phones, they had antennas that retracted and extended. But nowadays, almost universally, smartphones will have the antenna encapsulated inside the case. But anyway, as a final preliminary note, radio frequency communications is what we use for data now, but this harkens back to terrestrial radio. I, for instance, used a crystal radio set that looks a lot like what you're seeing here on screen, that looks pretty, like I said, exactly like that. My Grandpa Cook had one, and you notice that you wire up a little antenna to capture the signals. You're not going to be able to choose necessarily from too many different frequency bands, but it works. Here's an example of a Motorola business class wireless router, and you'll notice that this one has several antennas. The reasons for the several antennas could be, for instance, maybe the Wi-Fi router is using MIMO technology where you can do multiple data streams on the same channel in frequency, or perhaps it's a multi-band wireless router where it's transmitting different signals at different frequencies. More on that in just a moment. The 802.11 standards. All right, here we come with the stuff that you need to memorize for the exam. Once again, although I use the M word, memorization, in a somewhat negative way, this is something that's worthwhile to memorize because, as I said actually in the previous module, once you pass your A+ exam, you'll still rely upon this knowledge, having it in your brain, as you do network troubleshooting. For instance, if you're called to a customer's location, one of your first questions, if it's a Wi-Fi problem, is you're going to want to know which Wi-Fi standard or standards that Wi-Fi LAN or WLAN is using. And by the way, just parenthetically, IEEE stands for Institute of Electrical and Electronics Engineers. And this is a professional association that's located in New York City in the USA. It's been around since 1963, and they're all about maintaining standards. So they actually formally define in their 802.11 specification Wi-Fi. Now, wired Ethernet is the IEEE 802.3 standard. So this isn't just Wi-Fi only. You'll find if you visit the IEEE website, they have many standards in data networking. Anyway, back to our regularly scheduled programming. 802.11a operates at the 5 gigahertz frequency. Now, these frequencies refer to cycles per second. You could look at it as, in your mind, as a sine wave projecting in all directions horizontally out from an antenna, and the frequency determines how fast that wave moves. The two basic frequencies used in Wi-Fi are 2.4 gigahertz and 5 gigahertz. Even though 802.11a is pretty fast, I mean 54 megabits per second isn't exactly slow, but at the same point in 2015, 2016, you can get a lot faster at cheaper price. The problem with A is that it's not compatible with the other 802.11 standards, which means you need essentially proprietary equipment. So for that reason, 802.11a is rarely used. I've actually never seen it myself in business. The range is also something else you want to consider. When you're looking at Wi-Fi, you're thinking of which standard you'll adopt, and that's going to determine which frequency it operates on, your data throughput, which is your data network transfer speed, and the range. In other words, the distance from your access point and the Wi-Fi client device, which could be, say, a laptop computer or a smartphone. You'll notice that 35 meters or 115 feet isn't all that much distance, and that's absolutely true. For that reason, in business, depending upon how big your office is, you're almost always going to have to invest in more than one access point to give adequate coverage throughout the business. Now, the B, G, and N standards all can operate at the 2.4 gigahertz band, so this means you can actually have a WLAN that listens for traffic and accepts connections using B, G, or N. You might have a user with an older smartphone or older Wi-Fi card in their computer that can only do, for instance, B internet, and that's super low speed, 11 megabits per second. By contrast, nowadays, certainly we're talking at the least G, which gives 54. That's parity to the old antiquated 802.11a. But even more to the point, we find that the N standard, which is much faster, up to approximately 150 megabits per second, and much better range, up to perhaps over 200 feet, you might think, well, that's a pretty hotshot standard. Why don't we do that? And actually, N is an especially nice standard for many reasons. Notice that its frequency operates either at 2.4 or 5. The 802.11 AC standard is the latest and greatest as of this recording. That's a 5 gigahertz frequency, can go up to almost gigabit speeds, and this is crazy when you think that this is wireless and not wired Ethernet, but notice that its range is still approximately 100 feet or so. Maybe you can get 150 feet out of it. But coming back to N for a minute, notice that that's dual band. It can be 2.4 or 5. The problem, the Achilles heel of the 2.4 gigahertz band is interference. Cordless telephones, microwave ovens, Bluetooth, which also operates in the 2.4 gigahertz band, will definitely create interference with your 802.11 Wi-Fi signals. I have that problem at our home, as a matter of fact. So wherever possible, if you have a Wi-Fi network interface that can support 5 gigahertz, use either N or AC. Of course, the access point would have to support those standards as well. Now let's take a look at channels. Specifically, when you're configuring a Wi-Fi LAN, you're going to decide on a standard, right? Like maybe you're going to support B, G, and N all together. Well, aside from that frequency, the frequency band will have different channels within it. Specifically, the 2.4 gig band in the United States has 14 channels that are spread 5 megahertz apart, and that involves overlap. The channel availability for RF communications is regulated by country. The FCC in the United States is the governing body at play. And this graphic that I borrowed from Wikipedia illustrates up above, you can see those 14 channels and their degree of overlap. Of course, if you're in a business office or if you're in a residential neighborhood, you probably have several neighbors who are also broadcasting 2.4 gig Wi-Fi signals. And the more congestion you have on a particular channel or an overlapping channel, the more possibility of crosstalk and interference. So the idea is you want to choose non-overlapping channels. As you see below, the 4 non-overlapping channels for 2.4 gig Wi-Fi are 1, 6, 11, and 14. So of course what you'll want to do is perform a survey using a Wi-Fi snooping tool to see what your neighbors, your business neighbors or your residential neighbors are using, and put your 2.4 gigahertz WLAN on a different non-overlapping channel. I'll show you that in a demo in just a minute. In the 5 gigahertz range, the higher speed range, this is A, of course, but N and AC specifically. Here we have 23 non-overlapping channels in the US. So there's more channels to choose from, which is a good thing. Selecting the right channel is a powerful tip because it's going to give you a more stable, more performant Wi-Fi connection. In this first demo, we're going to take a look at Wi-Fi surveying / snooping tools. I'm on a Windows 8.1 workstation right now, and I downloaded Acrylic Wi-Fi. Check the course notes. I give you some links to various Wi-Fi snooper applications on all 3 major operating systems. To that point, you should also check the stores on your mobile device to see if there are any snoopers there as well. Now, when I say snooper, I'm not saying that we're doing anything illegal here. Acrylic Wi-Fi is a free tool, and as long as you have a Wi-Fi card installed, I actually have a USB dongle plugged into my computer that has a Wi-Fi radio in it. So I'm plugging into my own WLAN. Now you'll notice that I've sorted by RSSI. This is received signal strength indication, and lower negative numbers, believe it or not, actually denote a stronger connection. So this guy up on top, of course, is my own Wi-Fi router. I set this up specifically for the lab. And what's especially cool about tools like Acrylic is that it leaves nothing to the imagination. We can see all Wi-Fi networks in our range. We can see the relative signal strength. We can see the channels that they use and which 802.11 standard is going on. As you can see, BGN is the predominant one. Nobody's using AC, interestingly enough. We can see the encryption protocols that are in use. WEP is not a good idea. It's interesting that Xfinity, who have been installing a lot of open Wi-Fi hotspots here in Nashville to allow their subscribers easier Wi-Fi access, those don't have any security on them at all. Actually, they do. I mean, you have to authenticate with your Xfinity username and password, but it looks like there's no encryption protocols at this point, which frankly concerns me a little bit. The other thing I want to show you besides these specifications is that we can get a picture on channels. Notice that this tool shows you your 2.4 gig access point channels and your 5. So you can see which channels are in use by network. And so the notion, of course, is that you're going to use this information as intelligence to choose a channel that's in the clear, so to speak. So it looks like up here at 14, I might be safe. Maybe here in the 4 or 5 area, I might be safe. But there's heavy congestion on channel 1, of course. And we can see that right here if we do a search. It looks like 1 and 11 are most common. Unfortunately, I'm also on 1, so I'm sharing the same channel with some other networks near me. Might want to take a look at that. Wi-Fi encryption protocols. Now, encryption refers to taking plain text data, or clear text, and applying a mathematical algorithm or formula to that plain text, almost always in conjunction with a user-supplied key. A key would be a password or a passphrase, and then ultimately the data stream is obfuscated, if you don't mind the $5 word, the ciphertext, the hidden text that somebody who may be snooping your network and capturing packets off of it, they won't be able to decode those messages and obtain privileged information. It's as simple as that. So it's possible to do Wi-Fi with no security, but unless you're a business and you're committed to providing open Wi-Fi for your customers, it's not a good idea. You absolutely want to apply encryption such that you need to at the least know the correct password or passphrase to gain access to the WLAN. Now, WEP is wired equivalent privacy. This protocol's gone the way of the dodo. It's been superseded by Wi-Fi protected access, or WPA. Believe it or not, there are still devices that allow you to do WEP keys, but I strongly suggest you not do that. Those WEP keys aren't particularly long, 64 or 128 bits. But the key crucial problem with WEP is that several years ago the protocol was revealed to having a very fundamental vulnerability. Look at left here. This is kind of a complex drawing, but if you take it piece by piece, you have this pseudo-random 24-bit long value called an initialization vector that the access point or your client device creates. And that's combined with whatever WEP password you choose to protect the network with. You run that through an algorithm, a mathematical formula called RC4, and that is how you take plain text and turn it into ciphertext. Here's the problem. It's possible, very possible and easy, to brute force what the initialization vector is. So because a hacker would know that RC4 is the encryption protocol, and that's an open standard. If you're a hacker, you can learn exactly what RC4 does. And if you can guess the initialization vector, 50% probability that the same IV repeats itself after 5,000 packets, then all you need to do to break the key is guess the user's password. And most people tend to choose pretty weak passwords anyway, so hence, WEP is a fundamentally broken Wi-Fi encryption protocol. Instead, you should make sure to protect your Wi-Fi network with Wi-Fi Protected Access, or WPA. This is the successor to the broken WEP encryption protocol. The encryption is done in WPA using the Temporal Key Integrity Protocol, or TKIP. And TKIP, of course, will support a passphrase or a password. You don't want to choose 12345 or password. I would suggest you choose a passphrase. And for more information on choosing a strong password, check the course notes. But what's cool about TKIP is that it'll actually generate a new 128-bit encryption key per packet. Whereas WEP has one key for the entire data stream, WPA encrypts per packet. So you would have to crack every single packet as it's going between client and server, specifically the client Wi-Fi device and the access point, in order to break the protocol. So it's not impossible to break WPA, but WPA is very strong, especially if you choose a strong passphrase. Now, in order to make those potentially long passphrases easier to set up, and think of consumers who want to set up their Wii U or their Xbox One, and they just don't want to type a super long passphrase. It can get complex, some residential folks will tell you. There's the Wi-Fi Protected Setup, or WPS, which you see illustrated at right. This is a way for non-technical end users to simply press a button on their access point and whatever device they want to connect to that access point. And a PIN, personal identification number, is generated, a pseudo-random PIN that gets securely transferred between the devices and they become paired. So in theory, it's cool because it allows a non-technical person to easily apply WPA encryption in a WLAN. But the problem there, again, is the brute force aspect. Those pins have been shown to be relatively small So a brute force attack, if somebody has just written a script or is using some kind of automation software to just hit that access point iteratively, starting at 000 and moving upwards, all iterations. Computers can do those kind of repetitive operations very quickly. Once you guess the pin, boom, you've got yourself a WPA secured connection, and you may not really have any business connecting to that WLAN at all. So I would advise against Wi-Fi protected access in a business environment across the board. In a residence, I would personally, this is just my opinion, say it's okay to use because it's going to ward off all but the determined hackers. Somebody would actually have to target you or your family in order to exert enough effort to try to break into your network. And frankly, that's probably never going to be the case. If somebody does try to scan your neighborhood, doing war driving, for instance, they might detect that you have a WLAN, but they'll turn away and look for an easier target if they see that you're protected with WPA. As you know, in technology, you move from version 1 to version 2 to version 3 of hardware and software, and normally the idea is each successive product version or software version gives you new features. WPA2 does in fact operate along the same lines. WPA2 is the successor of the original WPA, and you'll find nowadays in most wireless routers, you can choose either WPA1 or WPA2. Your reasons for choosing one or the other, in my experience, deal with complexity of setup and your security needs. First of all, the WPA2 protocol uses a different encryption algorithm called the Advanced Encryption Standard, or AES. Whereas the WPA1 encryption uses 128-bit keys, AES goes to 192 or even 256 bits. That's not a trivial change. It adds quite a bit of overhead to the network communications when you're using keys that long. So therefore, I don't know if I would suggest using AES and WPA2 in a home environment, but certainly it's worth it in business. Specifically for this reason, WPA2 has consumer and business versions. The personal version uses a pre-shared key, or a PSK. That's the same way that WEP and WPA1 work. You supply a single password or passphrase that serves as the encryption key for that WLAN. But WPA2 really shines in its enterprise mode. And the reason for that is that you can use different authentication schemes like EAP, which stands for Extensible Authentication Protocol, and Radius, which is a way to centralize user authentication. Now, this is much more difficult to configure, but worth it in business because let's face it, it gets very unscalable very quickly in a business where you're doing PSK WPA2, because every time a new employee comes in, or if you want to give a guest access to the WLAN, you've got to horse around, well, what's the key, what's the password, and employees will write the password down, and then the post-it note winds up getting picked up by a custodian, and suddenly you have unauthorized people connecting to your network, you see? So in WPA2, using some of those advanced enterprise protocols, you can actually tie Wi-Fi authentication to usernames and passwords, such that a user comes into work in the morning, they log into the network on their laptop, and they're seamlessly authenticated to the Wi-Fi. If you want more info on that, check the Pluralsight library, check the course notes for this module, and frankly, the CompTIA Network Plus certification will give you a lot more coverage along those lines. Now, Wi-Fi at home typically looks like this. You have what's called a Wi-Fi router. Now, officially, it's an access point, which means it's a device that has a Wi-Fi radio, receiver, and transmitter inside it. Most always, you'll have an actual physical antenna like you see here, maybe more than one antenna, depending upon whether you're able to do dual band. My router at home is a Netgear R6300 that can do 2.4 and or 5 gigahertz bands. Now, these Wi-Fi routers will normally have an uplink. The port is normally labeled WAN that goes to your internet source. Now, frankly, some internet service providers incorporate everything in one box. So in this case, the coax cable, if you're using, say, digital cable, would come from the wall and directly into your Wi-Fi router. But normally, if you're using traditional digital cable, your coax will come into the gateway, and then you will RJ45 out of the gateway into the WAN port on your Wi-Fi router. And again, home Wi-Fi routers will typically have a switch built in. This one has a 4-port switch where you can support up to 4 wired Ethernet connections in addition to quote-unquote unlimited wireless connections. Now in the enterprise and business, as I said, due to the relatively short range of Wi-Fi signals, you're going to need to put more than one WAP, as they're called, Wi-Fi access point, around the business. Cisco's been in this market for a long time. At left, you see one of their AeroNet Wi-Fi access points, and notice that it has antennas inside the case. It makes for a nice streamlined presentation. Some businesses that are concerned about not having wires and cables and electrical equipment visible will actually put their WAPs up on the other side of the drop ceiling so that they're entirely invisible. At right, you see a Cisco 2500 series wireless access controller, and what's neat about these is they allow you to corral all of your Wi-Fi access points and centrally manage them. Very useful indeed. In this second brief demonstration, I want to relay the theory that we've been learning with the real world. So I told you that I have a small office, home office, Netgear Wi-Fi router here in my office, and normally you'll administer a Wi-Fi access point by connecting to its web interface. In other words, you'd know the IP address of the router. You can get that various ways, ipconfig or ifconfig, depending upon your operating system. Or alternatively, some vendors like Netgear actually offer desktop and mobile applications. Netgear's is called Genie, that allows you to connect to the router and administer it. So what I want to show you here is, let's see here, it gives us these easy buttons that allow us to diagnose our connection to the internet, perform speed tests, and so on. The real important stuff, I think, are the configuration settings. Now notice that we have a built-in snooper here that shows, it looks like, the 3 strongest signals we're receiving. Now this is my own network, of course. And Netgear has put a lot of work into this, actually. You can do a lot of cool stuff. It can show you your Wi-Fi versus other Wi-Fis in terms of channels, and look here, change channel will take you to a separate page where I can easily modify that and switch it to another channel that's not overlapping with one. You'll notice that the name of your wireless network is called a Service Set Identifier, or SSID. And a common question that you'll get is, should I broadcast or hide my SSID? The truth of that is, I suggest broadcasting it. Yes, it'll be visible to your neighbors, but as long as you're using WPA or WPA2 and using a strong network key, it shouldn't be a problem. Even if somebody does try to access the WLAN, they'll give up when they try a few passwords that fail. The trade-off to hiding the SSID is that you have to know the name of the SSID to configure it, and that can be a pain in the butt when you're helping residential users or end users. Quite honestly, it's easy for me, frankly, to get frustrated here because this is obviously a dumbed-down interface, and I mean that with all due respect. It's intended at a non-technical audience. I prefer interfaces that have an advanced view that allows those of us who do know the technical underpinnings to quickly make the changes that we want to. Now back to the real world, let's address those 2 questions that we brought up at the beginning. How do I secure my Wi-Fi? Well, that's actually a loaded question, isn't it? A couple quick things you can do is putting a strong password on the router itself. When you've connected to the router's web, and when I say router, I'm talking about wireless router or wireless access point. When you make an initial configuration connection to that wireless router and you go to the advanced settings, you should be able to apply a password that prevents someone who has successfully connected to your Wi-Fi LAN from logging into the router and potentially making changes that hose things up and create a denial of service. As I said, you should also be using encryption and not leaving your Wi-Fi network open. You can go beyond and actually create filters of MAC hardware addresses that you're allowing and everybody else is blocked. But that is overkill, in my humble opinion, for most consumer end users. And in business, as the business gets larger, you certainly don't want to be manually maintaining MAC addresses. That's where you don't want to go. You want to go for a more centralized solution. Now, in terms of the legality of writing or connecting to your neighbor's Wi-Fi without their permission, in the United States, that behavior is actually illegal from the state level. Not every state has laws governing it. Many do. But at the federal level, there's computer fraud laws in place. So the idea is you do not want to connect to any network, whether it's commercial or residential, that you don't have explicit or at least strong implicit permission to do so. Explicit means I actually call my neighbor and ask and they say no problem. Even that can get fuzzy from a legality standpoint if there's any problems. And implicit means you go to, say, a Starbucks and they have a big sign saying Wi-Fi free, blah, blah, blah. That having been said, it's important to note that by leaving your Wi-Fi network open, you're subjecting yourself to possible legal problems because, for instance, if somebody were to war drive, park outside your home, ride on your internet connection, and do illegal activities, remember that those traces aren't going to come back to the IP address and MAC address of that war driver sitting out in the parking lot or the field. Those traces are actually going to come back to the IP address and MAC address of your Wi-Fi router. So be aware of that, please. For homework, I have 2 assignments. The first is I'm challenging you to log into your home Wi-Fi router. If you have just a wired Ethernet gateway, do some research to figure out how to connect to it. You may just use the default username and password. A little research should be able to answer that for you. And review your security settings, specifically for Wi-Fi routers. What can you improve? There's always a counterbalance because on one hand, the more you increase the security of your Wi-Fi network, the trade-off is that you're going to make the Wi-Fi network more difficult for users to actually use. So you want to strike a balance. Secondly, survey your home and determine whether you might need, say, a range extender or a second access point. I don't live in a mansion by any means, but our home is large enough such that when my wife, daughter, and I are upstairs, we suffer signal attenuation when we're using Wi-Fi. So I performed a site survey. You can use a free service called Ekahau Heat Mapper. The link is in the course notes. And you can walk around your house with your laptop, for instance, take a site survey, and then make the decision whether you need a range extender or another AP. For further learning, check out Avril Salter's course on Cisco CCNA Wireless. Her wireless LAN fundamentals is absolutely outstanding. Also, John O'Neill covers the CompTIA Mobility Plus certification. Just by that name, that should tell you that this is a vendor-neutral certification that's concerned with mobile devices, of which Wi-Fi is certainly front and center. So in his course, in part 1 of his course, he covers all the RF basics, the Wi-Fi basics you ever want. He also reviews the OSI model and the TCP-IP stack, which we covered in the previous couple modules. So in combination, these 2 courses are going to greatly supplement your learning here. In summary, Wi-Fi, I think, is a great equalizer because the same principles apply both in the smallest of home networks and the largest of enterprise networks. You're concerned with which 802.11 standard you're using, the degree of compatibility that's required, the coverage and possible interference sources that are there. So once you have those skills in your shirt pocket, you can be a very valuable asset to a business of any size. And also, I think I've hammered this point home enough that leaving your WLAN, business or home, it doesn't matter, unsecured and open, could have legal ramifications. So I hope just that knowledge is enough to motivate you to get cracking on improving security. In the next module, we'll look at small office, home office networking in more detail. Thanks a lot for your participation. I'll see you then.